Good morning and welcome to our chemistry class. Today we are going to be talking about states of matter and the kinetic molecular theory. First and foremost, we need to define what is matter. Matter is anything that occupies space and has mass. Now, what does the kinetic molecular theory, KMT, say? It says matter is made up of particles that are in constant random motion. Right? Very important to remember that. This is also sometimes referred to as Brownian motion, which was discovered by a man named Robert Brown in 1828, when he discovered some pollen particles moving in random direction when he observed them in water. So we are saying matter is anything that has got mass and volume, and it is made up of particles that are always moving in all directions. Now, what are the three states of matter that we are supposed to be aware of? What are the three phases of matter? We have got solids, liquids, and gases. In solids, the particles are closely packed and they vibrate within their fixed positions, and hence solids have got a fixed shape and volume. Right? As you can see from my diagram, you can see the particles are very close. They've got very small spaces between them as compared to the particles in the liquid. But the particles in the liquid, they are closer than those in the gases. The particles in the gases have got the biggest spaces between them, and they occupy any space that is available to them. So the liquid particles, they are much further than the solid but closer than the gas, and the liquid particles are having weaker forces of attraction than the solid. The solid is having strong forces of attraction that keeps it within their fixed positions. So what did we say here? We said solids, they have got closely packed particles. The particles vibrate on their fixed positions. The particles have got low kinetic energy. They have got strong forces of attraction between the particles, and hence it has got fixed volume. There are small spaces between the particles. They have got a fixed shape because the strong forces of attraction keep the particles within their fixed positions. Now, what about the liquids? What did we say? We said the particles are much further apart than in the solids, but less than the gases. The particles have got more kinetic energy than the solids, but less than the gas, right? And hence the particles of the liquid, they can move over each other. No wonder a liquid can flow, and it doesn't have a fixed shape. It takes the shape of the container. And we are saying the forces of attraction are weaker than in the solid, but stronger than in the gas, right? Now, we said these forces of attraction in the gases are weakest. No wonder the particles can move independent of each other and occupy any space available to them. And we are saying the particles are the furthest. Now, matter can change phase depending on whether you are heating it up or cooling it up. If you heat a solid, it can either change into a liquid or a gas. If you heat a liquid, it can become a gas. So that's what we are saying here. Solids become liquids or gases when they are heated. In the liquids, they become gas if the temperature is increased. And the liquids, when you cool them down, what happens? They freeze and become solid. And the gas, when you freeze, when you cool it down, what happens? It becomes a liquid or a solid. So very, very important. Now let's proceed and look in detail what happens when matter changes its state or phase. So there we are. Change in the states or phases of matter. Now we are going to be looking at the heating and cooling curves. Now, let's look at what happens when you heat a solid. When you heat a solid, when it reaches a certain temperature, it changes into a liquid, and that process is called melting. Now, when you heat a liquid, at a certain temperature, some gas bubbles will be seen appearing in the liquid, and that is called boiling. Now, when you heat a liquid, another process also occurs, which is called evaporation. But evaporation does not occur at a specific temperature. It occurs over a wide range of temperatures, whereby a liquid is changing into a gas. Now, when you decrease the temperature of a gas, it changes back into a liquid, and we call that process condensation. If you decrease the temperature of a liquid or cool it down, the liquid, when it reaches a certain temperature, it starts changing into a solid, and that process is called freezing. Now, it follows that you can also have a situation whereby the solid changes directly into gas, and that process is called sublimation. The opposite of that, where a gas is directly changing into a solid, we call it deposition. Now, let's just quickly run through the definitions that we have discussed shortly. What is the melting point? You are supposed to define it as it is the temperature at which the solid changes into a liquid, and it is measured in degrees Celsius. What is the boiling point? It is the temperature at which the liquid changes into gas, and there are gas bubbles in the liquid, and it is also measured in degrees Celsius. What is the freezing point? It is the temperature at which the liquid becomes a solid, and it is measured in degrees Celsius. Now, we must not confuse boiling and evaporation. Evaporation is the process whereby a liquid changes into gas, and it happens over a wide range of temperatures. So there is no appearance of gas bubbles within the liquid itself, as opposed to boiling. Boiling is a specific temperature at which gas bubbles start appearing within the liquid. Now, let's look at condensation. We talked about it here. It is the process whereby a gas changes into a liquid, right? Then sublimation, we also talked about it, is the process whereby a solid changes into a gas. And we say the opposite is called deposition. Now let's quickly look at the heating curve. What happens? When you heat a solid at time 0 here, the temperature increases as time is increasing until it reaches a certain temperature, the melting point, where the solid will start to change into a liquid. At that point, the temperature remains constant even though you continue to supply heat. Why? Because the energy that you are supplying is being used to overcome the intermolecular forces of attraction in the solid, between the solid particles, as it changes into a liquid, and hence the temperature remains constant until all the solid has melted into liquid, upon which the temperature will start to rise again. Now, you realize that at a certain time TA and the temperature BP, which is the boiling point, the temperature will remain constant even though you continue to heat your liquid. Why? Because at that particular point, your liquid has reached the boiling point, and the heat that you are supplying is being used to overcome the intermolecular forces of attraction between the liquid particles as it changes phase into a gas. So this is the heating curve of a pure substance, showing all the phases from solid, and here we have got a mixture of a solid and a liquid, because that is the time when it is melting. Here we are left with the liquid only, and here we have a mixture of the liquid and the gas as it bubbles in the gas, in the liquid itself. Now let's see what happens with the cooling curve. Very simple. If you take that same boiling pure substance at boiling point, and you start cooling it down, the temperature will remain constant for a while, and as at a certain time t1, it will start to drop until it reaches the freezing point, whereby the liquid is changing into solid. At that particular point, the temperature remains constant until all the liquid has changed into solid. And at that particular point, time t3, the temperature of the solid will start to decrease. Now let's explain why the temperature is constant here and why it is constant there. In the first phase here, we've got a mix of a liquid and a gas as the liquid was boiling. When you cool the temperature, the hot vapor on the surface of the liquid